All right, let's take a look at the next one, number 3. What is BC? Well, BC is this side over here on a right triangle. So this is just, well, we're looking for a missing side, this missing side on the right triangle. Well, how do we find a missing side on a right triangle? This is just our Pythagorean theorem. So let's name these things. Well, we know our hypotenuse is always across from the 90. That's our C. A and B doesn't really matter. So let's just call that A. Let's just call that B. Okay, so with our Pythagorean theorem, A squared plus B squared equals C squared. Substituting all those in, we can see that we've got a 12 squared plus B squared is equal to 37 squared. Now we're going to try to get this B by itself, so let's move that 12 squared to the other side with a little bit of subtraction. So subtract 12 squared from both sides. We get B squared equals 37 squared minus 12 squared. But remember, we're looking for B and not just B squared. So we have to undo that square with a square root. So let's take care of the square root of the left. And we also have to take the square root of the right-hand side, because what we do to one side, we got to do to the other. So the square root undoes the square, leaving us with just B on this side. And over here, we're going to evaluate this with our calculator. So let's put that in. So we've got the square root, so second x squared, that opens up our square root function. We've got a 37 squared, okay, minus the 12 squared. In this case, we get a 35. So B is equal to 35. Let's take a look at our next one. All right, so for our next one, it says, what is the sine of the ratio of angle A? So we're talking about sines here, so now we're talking about trig. So whenever we're dealing with trig, we always want to write down SOHCAHTOA so we can understand which ones we're talking about. SOHCAHTOA, and we're going to be using this a little bit as we go forward. So since we're talking about sine, we're going to use our opposite and hypotenuse. So everything is in relation to the angle A here. Well, angle A is this one over here. So if we need the opposite side, opposite of it is the 195. That's our opposite. The hypotenuse, our H, is always the side across from the 90-degree angle. Okay, so what we're going to see here is that the sine of angle A, that's our opposite over hypotenuse, or in other words, our opposite 195 over hypotenuse 197. And that's our ratio, the sine ratio of angle A. Let's take a look at number 5. So it says, to the nearest tenth, so we're going to be doing some rounding here, which is the perimeter of triangle ABC. So the perimeter is all the sides added up, right? So in which case, we're looking at, well, we've got this side, I don't know, let's call this Y, let's call that one X, okay? So we know that in this particular case, our perimeter is going to be this X plus the Y plus the 5. X plus Y plus 5. So we're going to be able to add all those together to figure this out. Now it's easy, we've got a 5 here, we just got to figure out what the X and the Y side are. So we're going to do a little bit of trig here. So you can pick any angle that you want to. I'm going to choose this 29-degree angle down here. Okay, so if we're looking at this 29-degree angle, we can see that we've got our X over here and our 5 over here, the side that we know. So in this particular case, in relation to this 29-degree angle, this is my adjacent, this is my hypotenuse, the Y is going to be my opposite side. So let's set up some ratios here. So for side X, this is going to be the sine, the cosine. Look at me. Look at me, making mistakes all over the place. Cosine. Cosine, adjacent hypotenuse, cosine. Okay? That's why I wrote those for a reason. I knew I was going to need them. There you go. So the cosine of that 29-degree angle is the adjacent, the x over the hypotenuse, 5. So we've seen this before. Whenever our unknown is in the numerator, what we're going to do is we're going to move this 5, we're going to multiply it, a little cross multiplication here. So our x is going to be 5 cosine 29. Okay, so let's put that in here. So 5 cosine 29. Okay, in this case, we're looking at a 4.37. So in other words, approximately a 4.4. So approximately 4.4. Okay, we're going to come back to that. Okay, because we're going to add that here. And then our y. Okay, so to figure out our y, well, what do we have? We have an opposite and hypotenuse. Okay, so in this case, actually, let me rewrite this one. Since we're talking about opposite hypotenuse, we're talking about sine here. Okay, forgive me my mistakes there. So the sine, this time of the 29-degree angles, is our opposite, the y, over the hypotenuse 5. Okay, so if that's the case, once again, we're going to multiply that 5 sine 29. So y is going to be equal to 5 sine of the 29-degree angle. And we're going to do a little bit of rounding there. So 5 sine 29 this time. We're looking at approximately a 2.4. So approximately a 2.4. So we're going to use that, and that 5 there. So let's add that all together. So our perimeter is our x, our 4.4, plus our y, the 2.4, plus that 5 that we were given in the first place. So our perimeter, let's add those up together. We got a 4.4 plus the 2.4 plus the 5. Altogether, we're looking at about 11.8. 11.8. And that is our perimeter.